Hello, everyone, and welcome to DDL episode 8. And today we are going to be talking about taming the chaos. And what do I mean by chaos? Well, if you've been paying attention to the world of data lakes and table formats and catalogs, there's been quite a bit of chaos. And I'm joined today by Vinoth Chandar, who is the founder of Onehouse and co-creator of Apache Hoodie. And I'm delighted to welcome him to the show. Welcome, Vinoth.
Hey, Shirshanka, great to be here. Thanks for having me, and hope I don't get blamed for all the chaos here.
Well, you definitely have had some role to play in it, and we're going to talk about it. But first of all, quick intros. I'm Shirshanka, CTO and co-founder at Acryl and founder of the Data Hub project. We run a pretty large community of data practitioners and data enthusiasts, and also have a commercial product based on Data Hub that we call Acryl Cloud. Over to you, Vinod.
Yeah, so like I think you start off. I'm Vinoth. I founded Onehouse 3 years ago, building what we call the Universal Data Lake House, which is a way for you to get started with cloud data in the most open, interoperable way possible, mixing match the best of breed technologies for your diverse workloads. But I've also been running the Hoodie project as the PMC chair for almost 7 years now. It's been a long journey on that.
Wow.
And I think, yeah, I mean, it's nice to connect with you, Shishanka. We go a long way back to LinkedIn days where we were the old days when with no cloud, we are building everything by hand, writing databases and deploying them to production. So good to connect on a chat like this.
Absolutely. Vinod, tell us a little bit about your path to founding a data infra company. I mean, you and I worked at LinkedIn in the distributed data systems team. I was working on a distributed database myself, Espresso, and you were working on another distributed database back in the day, Voldemort, and then it
Yeah.
transformed into Venice over the years. So tell us a little bit about what happened since then and what was your path to founding a data infra company.
Yeah, so from right from where we left off there, as you know, I joined Uber, and then this was I think, and we basically Uber and hypergrowth phases where we're 4xing the business at like monstrous scale every year, and it was like a fun journey. So our first, I think I would say we applied all the best of breed kind of standard things that we learned from LinkedIn. We applied all those lessons at Uber to build our data foundation, and we're still left with a place where we were in a rock between a rock and a hard place, between a data warehouse and a data lake that was too slow. So we ended up creating what we call the transactional data lake, which goes on to become the data lake house now. And for me, I spent some 4 or 5 years in the community, building the community around it. And we started Onehouse because we thought even if you have like really cool Lakehouse technology, I think there needed to be like an easy to use cloud managed service, which can make this technology the mainstream, the de facto way for you to build data. And yeah, that's been a very interesting journey for me, from building, for example, the world's first data lakehouse, if you will, before the term was coined, to actually now seeing this become like the converging point in the cloud on data. It's been like a pretty wild ride, to say
Yeah,
the
pretty
least.
cool to see, technical folks build projects and then go on to found companies around them. It's kind of a story that has played out multiple times. I ended up also doing something similar with, creating the Data Hub project and then kind of making it successful at LinkedIn and then seeing it start to get successful outside and then creating a company around it. So it's very interesting. As technical founders, we still usually stay close to the code and close to building and close to the architecture, but also learn a bunch of new things like how to sell and how to market and how to talk about our technology, like to people who are way up in the business layer. So it's been fun for me as well, and I'm sure you've had similar growth in your own personal journey. But we're here to talk about data lakes and catalogs.
Yeah.
So maybe, Vinod, take us back to why this even happened. How did we get here in terms of data lakes? Why is this even a term? And we can talk about some foundational concepts really quick, and then we can get to the fun part.
Yeah, so very quickly, right? As you know, like back in the day, even when we were building Espresso and Voldemort, we were kind of like migrating from Oracle, right? So the good old days of like relational database, closed system, does great things, well packaged together. I think, as you know, that was the start of the whole like open data systems. Like these key value stores that we're building were one of the first open source data systems. If you now look back at them, right? So. And when we built we needed more data, we moved to building HDFS and Hadoop data lakes. Like we famously powered a lot of these people you may know, blah blah blah, all these like data features at LinkedIn using that, right? So end of the day, we went into this paradigm where we're storing files on a distributed file system as the thing, and then slowly evolved into, I think we realized, we needed SQL. So we wanted to make those files look more like tables, and then Hive was born, right? But really the next step for me, and this is where I left LinkedIn, is like Hive was sufficient at LinkedIn, at least at that time, right? But at Uber, we had like transactions. We needed like to migrate workloads from like a data warehouse which had transactions. It had updates, deletes, and we had to move ETL pipelines to be incremental and all of that. So these transactional capabilities were missing in Hive. Right. So essentially, we built, I think, these stable formats or lakehouse storage technologies, which are however you want to call them, essentially build like an additional set of metadata to bring some of these transactional capabilities back. And now you're in an interesting point where there is open file formats. There is some technical metadata that lives on cloud storage. There is some amount of technical metadata that lives in meta stores, and there is some metadata that lives in catalogs, right? So maybe I'll throw this back to you and like kind of understand how you view the whole metastore kind of evolution here as well.
Sure. So just to kind of repeat what I just heard from you, we first had tables in a database that was easily queryable using SQL. And then we said, this doesn't scale. Let's build distributed file systems, essentially create files and folders and drop all our data in there and just query them using some other crazy ways. And then decided, well, that doesn't work either. We really like our tables. So we put a layer on top and said, okay, now we got tables. And then we put SQL on top. And then we've kind of started to walk back towards getting back that database abstraction that we really started with. But now perhaps the underneath storage and query engines and the compute layer has become 10 times or maybe 100 times more scalable. So I guess all of that innovation was sort of worth it, right?
Yeah, definitely.
Cool. So on the catalog side, and I actually came at it two different ways. So my role at LinkedIn was really the technical architect for the data platform team. So I had to deal with data ingestion into the lake, and we were not running one Hadoop cluster, just like you guys at Uber. We were running like multiple Hadoop clusters. So there was a whole team dedicated to just running HDFS at scale and then copying data around multiple clusters, and then making all of these folders and files look like tables. So Hive was definitely a big thing. But I was also responsible for making sure that our data analysts and our data scientists and our ML engineers were able to quickly understand what data existed where, which data to actually use, and what were the semantics of each asset that they had. And so while on the one hand, I was responsible for kind of scaling Hive and making sure Hive was staying alive and well, and actually over time, our team ended up moving to Iceberg partially for some of the stuff. And then over time, I think LinkedIn has ended up moving to Iceberg for pretty much all of his underlying table formats. But on the other hand, I was also responsible for this like cross-system understanding of what are all the tables, what do they all mean, and how are tables derived from each other, and what are all the columns, and that ended up creating Data Hub. So Data Hub was really formed as this system that was able to see across all of these individual systems and was able to understand not only table names and schemas and columns, but also ownership, also compliance metadata, and then moving up lineage, and then also different kinds of assets like pipelines were a thing, metrics were a thing, models and features were a thing. And so that's kind of the journey of the Data Hub and the metadata arc at LinkedIn. We kind of went at it from both directions. On one side, we were kind of working really hard to make sure tables on the lake looked like tables on the lake, and query engines could work with it like tables. And on the other hand, we were trying hard to make sure that everything else that was important across tables and concepts that were beyond tables were also being represented well. And we had that ability to run centralized policy-driven infrastructure across everything. So the privacy tech infrastructure, for example, that was essentially going over the entirety of LinkedIn's infrastructure, data infrastructure, and saying, I know where all the PII lives, and I know how to delete a specific member ID or the data for a member ID. And those kind of platform neutral questions and platform neutral decisions were kind of being driven by Data Hub from a programmatic perspective. And of course, there was the application experience. So being able to have employees take a look at stuff and discover stuff and understand where everything, that was kind of the journey of Data Hub. But that's, history. And in the last, what is it like? It feels like in the last 6 months or so, a lot has happened. I mean, for a while, data lakehouse technology had kind of, I won't say converged, but at least stabilized to saying, well, there is Iceberg, there's Delta, and there's Hoodie, right? So these three were kind of all usually mentioned in the same breath as table formats, on top of obviously the the Parquets and the Avros, and I guess Avro nowadays is going away. But in the recent times, there's been kind of a renewed interest in these table formats and also other things on top of them. So Vinod, you've obviously had a ringside view into this last 6 months. So take us through it.
Yeah. So, and first of all, I'll start with, I think even the table format, the term, right? I think I've written like an extensive even blog around it. I think even at that level, I think these three projects approached it very differently, I would say. Like Hoodie has been always like, pushing more as an open data lake platform, if you will. So we have a table format, but we're building like a platform that you can use to build like lakehouses, and Delta has its own like differences and stuff, right? But yeah, by and large, I think there is like a good set of common functionality, right? But then the more interesting thing in our lens started when the warehouses like Snowflake and BigQuery started adding support for open data, right? And I think it's easy for us to forget how new this is to the entire industry, right? So typically warehouses are closed systems where the data sits in like proprietary file formats. I think probably this is the first full whole year where we've had major cloud warehouses have like full support for querying some Parquet based, table format support, right? So I think all of that also has forced, I think, some kind of like and brought interoperability in the mainstream, because you can choose different things on the like different format, if you will, table format on the writer side, and then your reader query engine could be supporting something completely different, right? So so we build this thing called One Table because our platform is we store data on top of Apache Hoodie. That's basically how we get the speed, cost, performance differentiators that we have on like for these ELT workloads. But then we want Snowflake users and Databricks users to be able to query that data as Delta, right? Photon, for example, works really well on Delta. So how do you bridge that gap? So we built this interoperability project called One Table, and Databricks has built a similar thing called Uniform, right? And then we've actually kind of like, if you look at it right now, One Table has, since we open sourced it with Google and Microsoft, and it's now Apache incubating as Apache Xtable. And we've kind of like now, I think across the aisle, there's like great work around the interoperability. I think every major like vendor, I think, has had a good embrace of, okay, there are these three table formats, if you will, and then we need to kind of like interop between them, right? So two notable examples, right? As recently
and just for folks that are tuning in or have been listening to us, just put your questions in the chat. We're going to be taking them at the end. I don't want to stop Vinod from speaking right now, but I just wanted to let you know that we'll be taking questions at the end. So keep the chat going and keep asking questions. But back to you, Vinod. You were talking about interoperability between and how One Table and Xtable have been pushing that.
Yeah, but I'll just probably highlight this as two examples, right? So there is like the recent build announcement between Snowflake and Fabric, the Xtable's powering the interop between like Iceberg to Delta Lake to Iceberg, And if you look at we did like some good work with Databricks around like making Uniform and Hoodie more interoperability. But it's great for us to see that beyond the table format conversations and the chaos, as you called it, we also like done a good amount of work trying to bridge the interoperability, because end of the day, we are rowing in that same direction where we want to make the data open and kind of consumable to all engines alike, right? So that's a major development. And I know like there's a bunch of news around the catalog space as well, which is more in your backyard. So maybe like
Well, not sure if it's backyard or front yard or living room, but absolutely, there's a bunch of news that has come up on top of some of these interop layers. First off, it was really Snowflake, I think, that announced Polaris, which is really a reference implementation, or targeted to be a reference implementation of the Iceberg Rest Catalog API. Iceberg, I think, as a project, had an open API spec lying around for their REST catalog specification, and Polaris, I think, is going to be coming out, or has already come out with an implementation of that. It was followed pretty literally next week by the Unity Catalog team. The Unity Catalog, if people know, is a commercial catalog that's offered by the Databricks platform. But the Unity Catalog team also announced that there will be a Unity Catalog open source project. In fact, Mate famously open sourced it live on stage, which was quite exciting to watch. And then those two projects have been getting quite a lot of attention recently, because people are like, wow, finally we have a few catalogs coming out in the open source. Of course, people have asked me quite a few times, like, is this the same as Data Hub? Because Data Hub is also an open source catalog, or are these different catalogs? And we can talk about what the minutiae are and how they're actually pretty different. But yeah, it's been a phenomenal last 6 months for catalogs and table formats. And Vinod, I feel like every time I watch a conversation that goes so deep and it's so geeky, and in the last 10 minutes, we've probably reeled off maybe 15 technology names. Like, even I can't keep track. Yeah. You said Uniform, that's wrapped by one table, or maybe it's the other way around, or I honestly can't keep track. And it's my job to keep track, because I'm supposed to integrate with all of these things and make them all look uniform, not to borrow a phrase, for a lot of humans and programs. So I was thinking, what if we actually just drew live? Like, we just, like back in the days, we used to have whiteboards and we would just scribble. So what if we actually took all these technologies, put them in the soup pot, and then said, okay, how do they all relate to each other? So we'll try something different this time, and we'll see how it goes. It's going to be live, and it's going to be pretty interesting. We'll basically open up a canvas. We'll put all the technologies in one corner, and then we'll try putting them up together to the best of our knowledge, and understand how the layering works, and talk about how they talk to each other.
Yeah.
So let's do it. Let's bring that up. So this is going to be interesting to kind of have all of this up on screen. So if people can see the screen, let me know. Vinod, can you see it?
Yeah, I can see it.
Okay, perfect. So you'll see we've got like a whole section of technologies. We've put all the technologies we could find. There's probably 100 more, but these will do, I think, because they represent a fair spread across a bunch of technologies and layers that we've talked about. And what we'll do is kind of start building up kind of the stack as we go. So let's start with obviously the most important piece of the stack, which is storage. So let's get storage in here. Let's see it. Here we go. Storage is here. Storage is in the house. And then let's just build a little box for storage. Wow, this background is kind of okay. Let's just say storage is blue. So what goes in here?
Yeah, it's your typical, if you're still running HDFS or
we've got S3, GCS.
GCS or any cloud storage, are this, right? This is the base layer.
And this is where you get your files and folders abstraction or buckets abstraction. And then, most people, in many cases, I honestly, it's quite interesting. I still see data teams using just folders and partitioning strategies by just, naming the folders date equals something and, saying, we've got something here.
This has been that's an interesting observation, and users like that. My 5 years of interacting with the users, in the community, people like that readability, and there is like an actual navigable structure to that thing. So yeah, it's still a mainstream ask.
Next level up, file formats. So what are file formats? These are things that make these files, decide what those files look like, how they are stored and encoded. We started out as an industry with Avro, I think. That was kind of the first one that Hadoop came out with. And so we'll put Avro over there. It's fast fading in popularity. Although for streaming data, I think a lot of people still prefer Avro because it's kind of easy to append to less complex memory constraints. Columnar formats like Parquet and ORC emerged. Parquet, I think, won the popular vote. If there was one, a lot of people use Parquet, and ends up being.
On that note, we do this hybrid storage where we land data in Avro. It's like much lighter for writers to do that, and then we amortize the Parquet writing costs. It gives you better compression. So how do you merge and read, for example, it lands as Avro, and then like you can tune how much you want to batch before you write a Parquet file. So this kind of gives you like the speed versus query efficiency trade-off.
Oh, that's interesting. So Parquet still lives on. Avro still lives on.
Avro still lives on.
That's cool. All right. So what else is there with file formats? Are there closed file formats?
Yeah, so that's the other thing, right? We generally in these conversations, we typically talk a lot about open source technologies because they're out in the open. It's easy to like talk about them, compare them, contrast them. But a vast majority of the data, sits in like proprietary file formats, right? So you need to. So when it comes to especially this conversation around catalogs and metadata, you need to care about that data as well because there's like a huge amount of data that's already sitting, workloads already running on top of these closed file formats as well. And even as we will move towards hopefully open being the default across all systems, maybe in the next few years, Warehouse is still the default file format is a closed proprietary file format.
And I guess just from a correctness perspective, in those scenarios, is Snowflake's proprietary file format still sitting on top of S3? I guess, right?
It does. For Redshift, for example, there's a couple of options. There is Spectrum, I think, which can query like storage is decoupled, and then there is like a in local storage architecture as well.
Cool. So file formats were a thing. They've been around for a while. And then what happened? Then we had table formats, right? Table formats emerged. Yeah. So let's get table formats in. All right, we've got table formats here. And what are our table formats? Let's get a. All right. I've gotten the box in here.
Yeah, probably the most kind of like I think a lot of maybe how this shaked out. This layer was very. Instrumental, I think, in causing the shakeup in some sense, because it started to blend the how you can now see this, right? It kind of brought some functionality common across closed and open file formats. Part of this functionality was sitting in a proprietary way inside warehouses. Now this kind of like opened this whole thing up, right? That's kind of why you see the big shift kind of happening from this layer.
And so the big thing you get when you move from the file format layer to the table format layer really is the abstraction of a table, the ability to insert, upsert, append, all of that stuff, right? Is that fair? That's like the big win.
Yeah, you get like, like atomically being able to read and write, snapshot isolation. So what even makes a table? What collection of files make up a table as of a point in time? And track additional metadata around across these file formats. For example, you want to have statistics collected across your table. That needs to live outside of the file format, right?
Correct.
We'll probably touch upon this when we get to Hive. That this was like kind of the missing thing, right?
Got it. And I won't ask the polarizing question, but do data engineers or folks building data stacks, do they have to wrestle with this choice? Like, am I going to use Hoodie, or am I going to use Delta Lake, or am I going to use Iceberg, or have all the formats kind of built pretty much the same capabilities or innovated in approximately the same way? Or is there still specific innovations that are still within specific formats? And so depending on which workloads are important for you, you end up choosing maybe to keep certain kinds of workloads on certain formats and certain kinds of workloads in other formats. Is that what's happening?
Yeah, that's basically how it's kind of like shaking out now, right? So there are definitely some obviously, if you compare all databases, all of them do DML statements and whatnot, right? But obviously, there is a difference. There is Postgres. There is a place for Postgres. There's a place for MySQL. There's a place for so it's more like that from that standpoint, right? There are deep design kind of trade-offs that each of them make.
And we'll not go into that in this talk, otherwise we'll be like here for 2 hours.
But that's 2 hours. So that's basically where there are deep. But the key thing I want to drive home, and maybe like a good segue into the next layer, is that's why we needed an interoperability layer, because there are real benefits to be had by choosing the right, the correct write format, and then reading them as like anything else, basically. Right.
Got it. So the table format interop layer, and we're just going to call it maybe interoperability for now, for lack of a better name for the layer.
That works.
And let me get a little box in here as well. Here we go. So this is the interop layer that we've needed to allow data practitioners to choose specific formats for specific workloads and kind of future-proof those decisions maybe to some extent.
Yeah, exactly right. So for example, if you want to do like a very fast incremental merge for your ETL pipelines, you can pick Hoodie as a writer, and then you can still query the data through Xtable on Snowflake or anything that supports Iceberg or Delta Lake, anything supports Delta Lake, right? So you're able to actually reduce cost on your ETL while you can pick the best of breed engine, like without being held logged into even one table format, if you will. So because end of the day, again, the thing that makes this possible is, remember, most of the data is sitting in this file format layer, right? This is a smaller amount of metadata that you're writing, so it's easily translatable across. And so this is like and as you will see, this is like a very, this did a very important thing for catalogs, as we will see how it enabled them.
So when we talk about catalogs, I think a lot of people get very confused. This is something I've noticed because OG database people don't get confused because they know what it means. But a lot of newer folks, because the word catalog has been used in so many different ways, they definitely get very confused. And so what I have found easier to talk through is the concept of a metastore, because especially for people in kind of the data lake domain, they understand the concept of a metastore almost more easily than the concept of a catalog.
Right.
Because, I think the Hive metastore kind of brought in that terminology to some extent. And I don't know if this terminology will stick for a really long time. Probably not, now that everyone's calling themselves a catalog. But I do think that the concept of you've got stuff on a distributed file system, you create an abstraction, you've got the right serialization format, then you create an abstraction of tables, and now I need to just plan my query and do queries against it. And so what are the facilities that a query engine needs to be able to
Yeah.
query these bits and bytes in a sane way was really what kind of prompted the Hive Metastore interface, right?
Yeah, exactly right. I think it's great that you drew out that distinction. For Hoodie, for example, we have something called a Hoodie Meta Server, which is like named in the same spirit. But the question I have down the line for you is how you see these lines blurring. Like, will they all converge? Or like, that's some question I have. Maybe like people want to chime in on the chat with if you have the same question as well. But yeah, I agree with you. This is technical metadata. I think you see a lot of people referring to it as technical metadata that's needed for reading, writing tables in an efficient, performant way and enforcing some access control for all these engines. That's what this layer does. Right?
And so
then you have
typically
open
it's like a DNS service for files and folders, essentially, right? You say, I want to access this table and here's my where clause. And it's the job of the Metastore to say, well, if that's what you want to do, you probably want to read these files in those folders. And by the way, here's the sections of the files that you should be reading because I already planned the query for you and I already have some statistics that tells me where all the data lives.
Got it. So would you place, for example, like Unity Catalog and Polaris here or a layer above?
So Unity Catalog and Polaris, absolutely, they belong here from an open source perspective. So the open source Polaris and the Unity Catalog open source are exactly in this layer because they are essentially helping the query engine do its job better when it's writing to tables or accessing tables.
Exactly.
Now, Unity Catalog has two variants, so maybe we should just, add a little disclaimer here and say.
I think we should maybe add a close, just like we did with open
OSS.
Yeah.
Maybe I'll just put the OSS stamp here, and then say, Unity Catalog OSS sits in the Metastore layer or the query engine catalog layer.
Right.
And then let's talk about closed catalogs at this layer.
Closed Metastores, I guess.
Yep. Closed Metastores.
Yeah. So
I mean,
this will be your glue,
yeah, glue is,
for example, absolutely. It's a clear example. Horizon, which is like Snowflake's, I think, like closed catalog. Is this like a Metastore or a catalog in that definition?
Great question. I think Horizon, from what I've seen from Snowflake's demos, belongs in a layer above. So I'll just move this to the back, and then we should be able to move Horizon out of here. I think AWS Glue is probably the dominant closed managed Metastore that I know of. Tabular probably was running one as well. So Tabular's catalog would be another example of that. And that's pretty much it. I mean, right? That's pretty much the
BigQuery Big Lake catalog. This probably like more closer here. I'm not exactly sure, but if I have to pick, I think I would say like that's the like a close.
I mean, one could argue that BigQuery belongs all the way down here with Snowflake and Redshift, right?
Actually,
where they give you pretty much all of these capabilities. So I'll drop BigQuery down here.
Okay, fair enough.
All right. So I think we're in a good spot. There are probably a few vendors and a few capabilities we are leaving out here. So apologies if you're one of those. I know how it feels, but we absolutely are trying our best to make sure we map all of the popular technologies that people care about and talk about. So that's our Metastore layer. So Metastore, popularized by Hive, obviously, and we have, Hive is an interesting one because I don't think it quite, if we were to draw arrows, Hive doesn't quite work this way with all of the layers below it. So Hive is probably like one of those Metastores that short circuits and goes, I don't know, maybe straight to the file format. Is that right?
Yeah, basically, if you consider Hive as a table format, if you will, it's basically queries files, right? That's
Yep,
basically
yep, yep.
what it does. And yeah, this is like an interesting thing for me. When we were like writing Hoodie, right, I think the main thing that we thought was some of the metadata that we're now putting on S3, like for example, column statistics, things like that. Those are things that are very scalable meta store, should have like just, stored and served instead of probably like serving this. And I almost feel like we are going back to that model where the meta stores are actually going to be performant at serving the stable metadata than some of these stable formats are being able to do. And but the table formats did the missing thing because I went directly to the file formats. The middle layer is basically what was built.
And I think, at least from what I've seen, Polaris and Unity Catalog OSS are currently going straight to Iceberg, I think, even though perhaps at a future date, they'll go through this interop layer. Is that right? Or is that not correct?
No, so it works in a couple of ways. I know less about Polaris. I think Polaris is more an Iceberg Rest Catalog. I think that's more direct, I feel. At least as I understand it, Unity Catalog does this. It goes from like Dell, I'm probably drawing the wrong color.
No problem.
But yeah, it's going through this. So what this lets Unity do is it's projecting, using Uniform to kind of project all these three tables formats, if you will, as like, into a same metadata structure, which then they can attach permissions to. And they have a, if you look at, maybe it's a good time to talk about the API layer. The API layer, they support, I think they support Iceberg Rest Catalog. They support their own API for Unity Catalog. And if I'm not mistaken, I think they also support HMS, I think, as a API for query engines to interact with.
I think that's true for Unity Catalog Closed. Not sure if it's, I don't think it's true for Unity Catalog OSS.
Yeah, I'm a little iffy. Yeah, I'm iffy on that.
Yeah, too. I think Unity Catalog OSS is, in fact, might actually be passing through to Iceberg directly right now, although that might change soon. So yeah, Unity Catalog is a little bit of a tricky one because there's the Unity Catalog project that, the commercial offering, and that does a few different things compared to what Unity Catalog OSS does. All right, so we need open metastore APIs. So that's the thing up here. And I think from an API perspective, it's probably like Iceberg Rest API that we hear a lot about, right? Iceberg Rest Catalog. And then, of course, there's the HMS API itself, which is a nightmare, but it exists.
Right. That's the the unagreed upon standard right now, which is the HMS, right? And then the thing for me, from my perspective, the interesting thing is, so there is two kinds of functionality that you wrote there, right? The access permissions and all of those things can easily be done at like a single layer in a table format agnostic way. But for you to read, write statistics and get into the metadata tracked in the table format layer itself, Iceberg Rest Catalog right now is very Iceberg specific, right? If you look at it, you for example need a Iceberg metadata reader to parse the response, right? So that's where I think either like we have a normalized representation of metadata across all of them, something like what Xtable does, or I don't know, maybe what I'm trying to say is the how this new metastore API going forward, whatever is replacing HMS, continues to work across the table format layer is kind of an open question right now, right? Because this problem exists even for like Delta Lake, for example.
Yep.
So like all three track, I'll take a simple example, like file listings and column statistics in different structures, right? Hive did not have this problem because, well, Hive bypassed this layer. But if you want to now deal with the table format layer and then support like a common, like a write read API for metastore, some work needs to be happening.
Yep. So I think it's going to be interesting to see whether the industry kind of converges on a single API. The usual problem with standardizing on APIs tends to be if you have an efficient query engine on the other side that's trying to take advantage of some efficiency that a table format or a file format has come up with, and if you've got a standardized API that doesn't give you those capabilities, then the query engine isn't happy and tries to bypass and go straight to the table format anyways. So the interoperability kind of drops in effectiveness very soon. So we'll see what happens. I mean, it's a worthwhile cause, and I think HMS just through adoption became kind of a standard, and I think that ends up being more common than becoming a standard by just anointing the standard. So we'll see how that evolves.
Yeah,
but
so very quick take on that angle is like, while we have a common API, the real question for me is Hive Metastore is also like something people run in production. It's like a production grade open source Metastore. So what is that? Right? I mean, beyond reference implementations, what is that going to be? Is that another question?
Absolutely. Yeah, a lot of the new OSS projects that have come out, like even Polaris and Unity Catalog, these are brand new projects, brand new code. They will, even if they become production grade over time, they'll need a ton of time to reach that level of maturity. Yeah. Cool. So that's all the way up to the Metastore, and at this point, we still have query engines talking to these APIs, right? But what happens above this layer is where things get into the what I call the everything catalog kind of layer. So let's get that layer in. And the everything catalog is an interesting one because it's got kind of a dual purpose. On the one hand, it needs to, and some people call it catalog of catalogs, it needs to know everything about everything. Like it needs to know that a file exists or a folder exists in some cases. It also needs to know that tables exist. It needs to know who has access to what table. It needs to know who has lineage to what. And even within this kind of category, we have definitely seen that there are different ways of approaching it as well. So from a use case perspective, we see obviously discovery, lineage, and quality being kind of top of mind for anyone who wants a catalog at this level where you can see across everything. And if you look at Horizon, for example, that's an example of something like this. However, only limited to the Snowflake ecosystem. So maybe even within this, you can create like a platform-specific version of this, right? And you say, well, for everything in Snowflake, I have Horizon, right? Something like that. And so that's kind of like a subset of all of the catalogs that you could have. And you can do the same thing with Unity Catalog. Now the non-OSS version, you can say, 1 second while I kind of find that logo for you. Where is it? Unity Catalog, where are you hiding? Okay, there we go. And so this is Unity Catalog commercial now. And that's also kind of a everything catalog in that sense, but limited to the platform. So we can say platform specific.
Makes sense.
That's kind of these guys over here. Data Hub is actually like an everything catalog across everything. So what we end up doing is, all of these things, like other technologies that you don't even include in here, like, SageMaker and Looker and DBT, right? Those, and Spark, I guess, is inside here, but sometimes it's also outside. So these kind of technologies that are outside, your data lake ecosystem in many scenarios. Spark is probably the one that I shouldn't have here, but these are good examples of like a transformation engine, an AI tool, and a BI tool, right? And these guys, usually live outside. So Data Hub's job really is to ensure that people can see everything across everything, and that, And so the way we ended up doing this is really by building what we call like a metadata platform, and so that thing kind of lives at all layers, and it essentially has connectivity into every layer of the stack. So it's able to see this, it's able to see this, it's also able to see this. And in some cases, there's also like reversibility, right? So for example, it can propagate tags back into Snowflake or BigQuery. So a lot of interesting use cases that people do with this is visibility, so getting metadata out, but then also after refinement, pushing metadata back out into these systems.
Makes sense.
So that's,
and we haven't touched things like streaming data, for example, right? That's another thing. This is an ecosystem
we should get
outside of this whole block diagram.
Correct. Yeah. So I absolutely, in fact, funny story, when we look at Data Hub ingestion stats and we say, what's the most popular system that people connect Data Hub to, we find that it's Postgres, MySQL, and a few of these other things that we don't usually talk about in kind of modern day data stacks. And the reality is that a lot of people are actually connecting us up to the entirety of the data stack, not just the data lake or the data warehouse. So that's kind of been pretty interesting to kind of see. So that's kind of the stack. Anything else that you would like to add here, Vinoth, in terms of how these systems behave, what they need to know about, and how they interoperate with each other?
No, this is actually, if you look at it, we I think landed with a picture where it kind of the two big boxes are this more of semantic layer, cross system, while a lot of the stuff that we drew the layers, a lot of them from the bottom were about data infrastructure on warehouse, lakehouse, lake, however you want to call it. So I think this hopefully brings some clarity.
Yeah, I think, and we honestly just scratched the surface of everything and how they relate to each other, but hopefully this helps people kind of contextualize what are these systems, what are they really representing, and you brought up a good point. We should just add semantics and cross-platform policies, that kind of stuff usually lives at this layer. So hopefully this was interesting. It definitely was for us to kind of get in and draw this out. I learned a few things, and I don't know, Vinoth, how you felt about this exercise.
I think it was good. I think mapping it out like this was also super interesting exercise. Built some clarity. I like to think in layers. It's very and it's exciting to see that there's open source in every layer. So it's kind of like a fun time to be working in the space.
Yeah, I think it's fun to see how, if you think of this, I mean, it's the today architecture. Some of it may, coalesce over time, but definitely in terms of ideal end state, we definitely see that this cross-system, cross-platform catalogs will continue to be important. And then individual platform catalogs will continue to evolve and try to be really good partners for the query engines that need to query and access the data that's in these platforms. We also see kind of logical things wanting to live outside some of these individual platforms. And I'm really excited to see where open table formats and interoperability layers are going to make query engines be a lot less tied in to specific implementations. Vinoth, any closing thoughts on your end?
No, I think it pretty much summarized that. And I think as you mentioned, the catalog and being able to easily share permissions across engines, that's like a core part of, I think, what will bring true interoperability. Imagine an enterprise, I have an existing engine, thousands of users with a lot of permissions across thousands of tables. How am I going to try a new engine? Right. So this is, in that sense, that translation piece is like very close to our hearts. So we are thinking a lot more around how to make that and unlock kind of like true freedom of choice for people to move across engines.
Cool. One of the things we have enjoyed partnering with the Hoodie team on is kind of the real-time integration that you built with Data Hub, because that really gives us the real power of a streaming real-time metadata platform where whenever changes happen, those get published instantly. And so that way we can be good custodians of the metadata and also transmit it over to other systems that need it instantly. And that unlocks a whole suite of capabilities across different platforms. So that's been kind of fun to watch. And I think it's been a testament. In fact, funnily enough, just 2 days ago, I just saw a getting started guide on Data Hub and Hoodie posted on our Data Hub community channel. And it essentially talked about using Hoodie Delta Streamer and streaming metadata over to Data Hub. So that was pretty cool to watch. But hopefully everyone had a great time listening to us geek out about table formats and data lakes and catalogs and everything in between. We're going to take questions in the chat and see you on LinkedIn. And thanks a lot, Vinoth, for coming on the show and spending time with us. I know probably a busy day for you as well, but this is going to be a fun time. And for folks who are around, please subscribe to our Acryl Data company page on LinkedIn, YouTube, or Twitter so that you can be notified on all of these latest and greatest hot takes, and sometimes also these architecty geek out sessions on data and AI technologies.
Hey, awesome.
All right. And with that, we can call it a wrap.